Hi, welcome to Making It Look Great, and we're on to part 12, and we're going to add a few more elements into our After Effects scene. So the first thing that we're going to do is we're going to bring in the large 3D renders that we created, one of the globe and one of the text news today. And then after that we're going to add in some particle effects, and for that we'll be using Trapcode Particular. If you don't actually have the plugin, you can download a demo version of it from redgiantsoftware.com. So more about Trapcode Particular when we come to that part of the tutorial. So let's move on and add in the other graphical elements. First of all, make sure that you've imported them into your 3D renders or the appropriate folder. I named mine Globe Large and News Today Large, and I need to make sure that they are interpreted with the correct alpha channel, and I saved mine out with a straight alpha. So if we alt double click Globe Large, we can see it in our viewer here. There we go, and everything looks okay. So if we come to the comp, what I'd like to do is bring these on at the point around 4 seconds, I think it is, where the globe zooms backwards. So let's move to the 4-second mark and let's drag down so we can see the bottom of the timeline. In fact, we can pull the whole timeline up so we can just see a bit more. I want this to go kind of behind everything except for obviously the background. So let's just grab the globe large and drag it in, place it at the back. If we press T for opacity, and let's just lower this down to around 10, and if we press the left square bracket, we can trim the in point of that layer to where our time marker is. So I don't want this to actually be visible at this point, but if we scrub forward, let's just jump forward frame by frame. We can do that by using the page up, page down. Okay, and at this point in time it is in place. So at this point I want to add a key for 10% opacity. If we press I to jump to the in point of that layer, we can drag that opacity down to 0. Now let's select the second key just by clicking it once, not twice. And if we press F9, we can then ease into that key. So now if we drag through, you can see that our globe is fading up and spinning round. I'm going to set the composite or blend mode to be screen. Okay. And the next thing to do is just to position this, and I think that really we should be positioning this so that it's in the same place as our sphere. Let's just drag the layer across somewhere around here. And if I then zoom out again, and let's just drag this back up, and we can just check that that looks okay. Cool stuff. So the next thing to bring in is the News Today Large, and if we double click this, we can see that in our viewer. Press the space bar to bring up the hand tool and we can pan through. Looks a little bit jagged, but that's just because it's not at 100%. At 100% it all looks fine. Okay, so come back to the main comp and let's drag this into the timeline, and we need this to be below everything as well. So let's just drag this in. It doesn't matter whether it's above or below the globe, to be honest. And there it is. Let's press the left square bracket to trim the in point, and I'm going to do the same thing and fade this up as well. So we probably want that to fade up at the same point in time as our globe is fading up in the background. So if we move to that key, let's press T for opacity. You can also hold down Shift and press S to bring up scale and P to bring up position. There's a good way of remembering this actually, and that's P-A-R-T-S, parts, and that's position, anchor point, rotation, scale and opacity. And you can remember opacity with a T for transparency. It's not quite the same, but that's how I remember it. Okay, so we have the opacity up, so let's just set that down to around 20 for now. I think that we could change the blend mode as well, and I'm going to try perhaps screen. It looks a bit too bright. Maybe, well, it's on black, so overlay. Overlay looks pretty cool. It's a bit big. Let's scale it down. Somewhere around 65%. I think 65% scale looks good, 20% opacity. The fact that it's on black doesn't really matter because we're using an alpha channel. However, if it was on black, we could choose to use add screen, but we wouldn't really get away with using multiply. But I think multiply looks a bit too dull anyway, so I think the nicest result here is with overlay so far. And you can always check out the other blend modes when you're building the project on your own. So the next thing that I want to do is just add a key here for opacity. Press I, jump to the in point, and let's set the opacity down to 0. And again, select the second key, press F9 so that we ease into that position, or that opacity should I say, that opacity value. Because the word is so long, we can actually kind of pan this across, which I think would look quite cool if we have this moving. So what we need to do is to set an in point for the position and then animate it to the end of the comp and set an end position for it. So if we press I to jump to the beginning of our layer, the problem that we have now is that we can't actually see the layer because we've got our keyframed opacity, so that starts at 0 and ends here. So we could just come to this point and position it there and then move the keyframe, but that wouldn't really be as accurate as we may want it to be. So there is actually a way of doing this with expressions, and what do I hear you cry? Expressions? No way. We don't want to use an expression for something as simple as this. We could just delete the opacity keyframes, do the position animation first, and then set up the opacity keyframes. That's all well and good, but if your keyframes were a little bit more complicated, or if you had quite a few, then it's not necessarily a good workflow. You know, we've set up our opacity keyframes now, so how can we work around this? I mean, the expression that you add is possibly the simplest expression of all as well. All we need to do is to Alt-click on the stopwatch for opacity. This will bring up our expressions kind of field. And in here, what we can do is we can just say, put 50. And what that means is that the expression will actually override the keyframes, so our keyframes aren't having any effect now. The last value in the expression is always the value that's used, and because we've put 50 in there, that means that this layer now becomes 50, even though we have keys on that layer. If we want to disable the expression, we can just click on the equals and then our keyframes work again. So just by adding in the number 50 there, we don't have to delete any keyframes and we can reposition this layer, no problem at all. Once we're happy with our position animation, we just click on here to disable the expression, or we can delete the number 50 out of there. And that will work for all parameters, but the opacity one is the one that it's particularly prudent to use it on, because when you have 0 opacity you can't see what you're doing, and this is just a really quick way of getting around it. So if you click and drag the layer rather than an alternative layer, and let's drag this across, and I think I want to position it so that the N is around here. And at this point we can press Alt-P to add in a position keyframe, and then let's just press End to jump to the end of the comp, and you can press Home to jump to the beginning. And now we're at the end of the comp. Let's drag our layer across. We don't want it to move too much, and at the end of the day it is going to just be a graphical element in the background. It's brighter than it will be now as well, so don't let that mislead you. So let's say move it to around here, just so that we see the news and a little bit of today. So as we drag across, you can see that it moves across quite nicely. So if we're happy with that, we can just come in here, delete the 50 out of our expression, and when we click off, the expression is deleted. And there we go. So now we have the big text news today moving across in the background as well. I think in hindsight, having looked at this, that our large globe is a little bit large, so let's come down, press S for scale with that layer selected, and let's just scale this down a little bit. We've got the center in the right point, so we can just kind of do it by eye. I think probably somewhere around 80% looks a little bit better. Okay, cool stuff. So that was pretty quick and simple, and those two elements rendered out nice and quickly, and I think that they've added a nice bed to the background and helped tie it all together. So we've got that far. Let's choose increment and save, and let's move on and start adding in some particles using Trapcode Particular. Okay, as I mentioned before, Trapcode Particular is a third-party plugin, so if you don't have it, you can either skip this part or you can go to redgiantsoftware.com and download a demo. If you are in the industry of motion graphics, then I would strongly recommend that you go and download it and have a play around. Go to trapcode.com, look at some of the examples in the gallery. In my opinion, Particular is the best particle system available for After Effects, and it should be a standard part of any motion graphics toolkit. Let's just have a real quick look at it before we bring it into this comp, just so you can understand what it is and how it basically works. So for this I'm going to create a new comp just going to go for a PAL square pixel and add a new solid to this, and then I'm going to go Effect, Trap Code, Particular. Okay, so when we first add it to our layer, nothing happens, but if we drag through, you can see that what's happening is we have lots of particles being spewed out. If we come to the layer menu and add in a new camera, and let's press C, or actually select the orbit tool, you can see that we can move around the particles, and they are actually kind of fully 3D. Now the thing with Particular is it does work on a 2D layer. If I press F4 so you can see that I haven't set this layer to be a 3D layer. If I click that, then it's going to warn me that effects that use cameras or light should be applied to 2D layers, because this is a 2D effect. Although it has a 3D look and it works with the camera, you apply it to a 2D layer. And by doing that, you can see that it's messed up the result. So let's uncheck that and leave it as a 2D layer. Now the version of Particular that we are using in this tutorial is 1.5. You can see it here in the preview window, and if we click in here you can actually see a preview. As I'm recording this, Particular 2 is about to be released, and I've been lucky enough to be beta testing that for Trap Code, and I know there's a few changes, so as I go through the tutorial I'll try to point out any differences between 1.5 and 2, and the first one I'll point out is that in version 2 we don't actually have this preview anymore. So although this is pretty cool and you can hold shift down and it will show you your particle system, it's been removed, and the reason for that is just to really make space for a lot more controls. The other main difference is that the settings window, when you open it on this version, has lots and lots of settings in here. As you can see, in version 2 they've all been brought into the main interface. This is much better for workflow, and it means that a lot of the parameters that you used to have to access these settings for, you can now access directly in the effects controls. Anyway, we're not going to go through the difference between 1.5 and 2. We're going to be adding some effects using this. We've had a quick look at it. One thing I'll just point out is that the emitter here has a position X and Y and Z, and as you can see we can move this around. If we move that around, it's moving in 3D space. We can move it backwards and forwards in Z, maybe not quite as drastically as this, but you can see that it's moving around in 3D space. So what we can do is we can take the 3D position data that we brought through from our Cinema 4D project, and we can use it to apply to our Particular emitter. So what it will look like is that our particles are actually moving around in 3D space with our 3D render. So let's just close Comp 1, come to the project window. I'm just going to delete this because I don't want this project, that comp in this project. And let's come down to our main timeline. So the way that Particular works, as I showed you, is you add it to a 2D layer. So if we open up our solids, we need to pick a solid that is the full size of our comp. We can delete this solid actually because this is the one that I just made before. So here we go, Black Solid 3. Let's just use this for now. And I want it to sit behind the globe and things like this, so that our particles can start hidden behind there and they can kind of zoom out. So if you remember, at this point in time, as these streaks come across, we added in some external compositing tags, and here we have the null objects that correspond to those. If I just unhide those, you can see them here visible in our comp window. Mine are actually visible black. Yours may well come through as transparent. I think that's a slight bug there, but not to worry. I'm only using them as nulls, so I can just set the opacity to 0. It doesn't really make any difference. The point is that if we select that, you can see the motion path from that object, and as we pull back, you can see that that null whizzes across in time with the streak that's there. So what we're going to do with this, we could add in some particles that kind of emit at the same point as this moving across. Now there's a few ways to do this. If we first of all come down to our solid, let's add it in at the bottom here. Let's just click and call this Particular. And then the next thing is to add the effect. Mine's at the top here, but if you haven't already added it, you add it from the Trap Code menu. Okay, and if we come to the beginning of one of these News Today layers, and let's just trim our Particular layer to there. So press I to jump to the beginning of that layer, select the particular layer and press the left square bracket to trim the beginning of that layer to that point. If we solo our particular layer and scrub through, you can see that somewhere here we have a few particles in the distance. And you can see that it's also moving because our 3D camera is pulling back. So we need to take our particular emitter position and link it to these null objects. So if we first of all take the top object and press P to bring up our position, you can see that at this point in time we have some position keyframes. I think in fact that's the point where it starts to whiz across, so perhaps we should start our particular layer from there, because otherwise we're only going to need to key the particle emission. So let's just trim it to there instead. So now our particles start from that point in time. Cool stuff. If we press E for effects and double click to bring up our particular effects in the effects control, fold down the emitter, we can alt click on the position XY to create an expression. This is only for the X and the Y parameters. We also need to link in the Z parameter. So let's just scroll so we can see our position here. We can't actually see the effect, so let's just deselect, select the layer, press U, which will bring up our keyframed or any parameters with expressions. Now we can take the pick whip and we can drag from the particular position XY and we can drag it onto our trace null top position, and that will then link those parameters. The thing is here is that we're trying to link a position parameter from a 3D layer to a parameter which only takes two values. So here we have a value for X and Y, and here we have a value for X, Y and Z. So what After Effects does for us, it's very clever, is it creates some temporary variables, and it assigns those variables to value 0 and value 1, and value 0 is the first and value 1 is the second. So what that now means is that if we click to accept that expression, that these values here will turn to 200 and minus 280 respectively, because they're now linked to here. And you can see that that's actually happened. And if we drag across, you can see that our particle line now whizzes across. Cool. So that's pretty useful, and if we drag through, you'll notice that the Z value for the trace null top, which is the last value here, doesn't actually change, because our streaks didn't move backwards and forwards in Z, they only moved across on X. So we only really need to link one parameter. However, if you did move it on Z, then it'd be useful to link that as well. So let's just go through how you do that. Let's alt click on our particular position Z to create an expression, and this time if we just scroll up so we can see our position for the trace null top, if we drag our pick whip up to that position, we can actually select which value we'd like to use. Let's select the last one, drag it here, and it creates the expression for us, and you can see that it's put position 2, and this is because we have 0, 1, 2. So although you may think that's the third, it is the third value, but it starts on 0. So now that's just going to stay at 0 because our null doesn't move on Z. But if you were importing something from Cinema 4D and it was moving on Z, then that's how you'd do it. So let's come back to our particle settings and let's just set this to be, say, 500. If we drag across, you should see a few more particles being emitted. And if we unsolo our particular layer, you can just about see the dots here. Let's zoom in and you can just see the particles being emitted as we drag across. So it's not really adding much to our project, is it? It's a lot of effort to go to for a minimal kind of look. And what I want to do is just show you something that will be far more interesting to look at, and it will also in the long run be more efficient to set up. Because currently we've got one particular layer and we're emitting one set of particles. If we want to also link to our other two nulls, we're going to need to add 2 more layers with 2 more sets of particular, and that will give us 3 particle systems. And then we may want to add in some sparkles and some glows and things like that as well. So we're going to end up with like 6 or 7 layers for our particle systems, and we can do it in a much more efficient way than this. And the way that we can do it is we can use a light as an emitter. Particular has an option to choose an emitter type as a light. If we come to the emitter type parameter in the effects window, you can click on here, you can see there's quite a few different options in here, and one of them is light. And that's what we're going to do. So we can create some lights and we can link them to these objects. But we're not just going to do that, we're going to take it one step further. So first of all, before we do that, let's just click in here and delete the expression. And let's click in here and delete the expression for this. This resets particular back to the default values. Now we've done that, let's add in some lights. Okay. So if we come to the layer menu and choose new, we can choose new light. This then comes up with our options. Now the name of the light here is very important, and I'll show you why in a moment. Let's just call this emitter, and I'm going to use a point light with an intensity of 45. I'm going to change the colour, and I'm just going to make this a kind of warm yellowy colour. Now the reason for that is because Particular will take the colour that you set for your light and it will use that for the particles that we create. If we click OK, we now have a light in our scene. I'm just going to drag this down so it's very near our null objects. We can actually hide our null objects because we don't want to see them anyway. We're just going to use them for reference to extract the 3D data from. Now I've got my parent column hidden. I'm just going to click up here and just show it briefly. And what I'm going to do is I'm going to take my emitter and I'm going to link it to the trace null top by dragging the pick whip here, and you can see that in the parent column this updates to show that it is now linked to that null. And if we scrub across, you can see that the light is in fact moving with it. The problem is that the light is in a different position in space, so although it looks like it's more or less lined up here, it may well be further backwards or forwards in Z. If we press P on the emitter, we can have a look at our position settings, and to make sure it is in exactly the same position as our null, we can zero these out. Once we've parented it, it will now use the coordinate system from this object. So if we zero these 3 position values, we know that this emitter light is now in the same position as our null, and there you go, it was the top one that it was linked to, so we can see that it's in the correct position now. As we drag across, you can see it's lining up perfectly. So that's pretty cool. But what I want to do is take this emitter, this light, and link it to Particular. So if we open up our particle settings, now in Particular 2, this option is in the effects controls, but in 1.5 you have to click settings and go into there. So let's click this. Actually, now we've opened it up, I believe I was wrong there, apologies for that, but it's just reminded me the 2 parameters that are still in the settings window with version 2 are the name starts with emitter and the light name shadow, and I do believe that is because they are words, and everything else is either a checkbox or a number, and they can all be put into the effects controls GUI, whereas the names can't. So in this dialog we have name starts with, and it's under the light emitters section. So this name here is very important, and this is why we called our light emitter. And we can basically change that because we can have various particular layers, and we can have various lights, and we can have the different particle systems linked to the different lights. In this example I just used emitter because that's the default. So the next thing that we need to do is we need to change our particular emitter type to light. When we do that, you can see that the position parameters are all greyed out. But now when we drag across, we should see some particles. And okay, you can just about see them there. It's pretty small, and you can also see that they're now yellow. So that's a very quick way of adding a 3D emitter by using a light. But we haven't really achieved anything more than we did a moment ago when we linked them up using expressions. The reason I wanted to use a light is because what I want to do is I want to kind of randomly rotate my null object and have my emitter light offset slightly so that it will kind of wiggle around the line that gets wiped across. So if for instance I set my emitter position to be 100 on Y, you can see that it moves, and if we drag across, it's now moved 100 on Y. So our null is here, whereas our particle system is here. Because we've offset the emitter from our null, if we then rotate our null, then this is going to rotate with that offset value. So let's select our null top and press R for rotation. You can see that it's got some rotation keyframes actually in here already, but we don't need those because we're only interested in the position of this object. So let's just hit the stopwatch to get rid of all of those. If we then take, for instance, the orientation and rotate it, you can see in the comp window here that the light is actually moving around. If we rotate it on this value, you can see that it moves around like this. So if we just reset these back to 0 and we set some kind of random expression on here, we can have this wiggle around, which will then make our emitter light wiggle around as it travels across, and we should get some particles drawing around these streaks. So to add the expression, I'm going to use a wiggle expression, and if we alt click on the orientation to create an expression, and then we can click on the expression menu list, scroll down to property, and in here we have the option to choose wiggle. So the wiggle expression does exactly what it says, it wiggles the values. All these parts in here are to remind us what parameters we can use, and the two that we're most interested in is frequency and amplitude. So let's just select all of this for now, and what we want to do is to say how many times we want it to wiggle and how much we want it to wiggle, and the times we want it to wiggle corresponds to the frequency and the amount corresponds to the amplitude. So if we put 2, that means 2 times a second, and then put a comma, and then for the amount, if we put 360, because we're working in degrees, that makes sense, so wiggle between 0 and 360 degrees 2 times a second. If we uncheck that, and now if we scrub through, you can see the light is moving around as it wiggles. And if we come to this point in time, you can just about see that our particles have indeed moved up and down around the line. So let's take this particle system and make it so that we can see that just a little bit more clearly. We've set up our null so it wiggles around on its orientation. We have our light, which is set to be an emitter, and that's parented to it. Come to particular. Let's look at our particle settings. Press I to jump to the beginning of the layer. Let's just zoom out so we can see the comp window fully. And in our particles per second, I'm going to set this down to be 0. So at the very beginning, I don't want it to be emitting any particles at all. Let's add a key here. And if the layer was much longer, if we drag this out, what that would mean is that there are no particles being emitted from this point in time at all. Let's just undo that. The next thing I'm going to do is just jump forward 1 frame, and I'm going to increase the amount of particles a second. I'm going to put a very high value here, something like 10,000. So it's going to basically emit 10,000 particles per second. So if we drag across now, okay, you can see that it's lots and lots and lots of particles being emitted. It's typical kind of fairy dust looking thing. If we move across until the point where the emitter is off the screen, which is around here, what I want to do now is switch it so that it stops emitting particles at that point. But if we add a key and set the particles to 0, what will happen is it will interpolate down and it will become from 10,000 to 0 between this keyframe and the next. Okay, I've just zoomed in on the timeline a little bit so we can see more clearly what we're doing. So if we click here, we can just add a key for the same value of 10,000. I think I can safely move that key back 1 frame, and now if I set this to 0, let's just click and do that. From this point onwards, it won't emit any more particles. However, we do need the layer to stay there, because if we just ended the layer at this point, all our particles will just disappear. And particles have what's called a lifespan, and we want them to carry on being displayed until their life is over. So we have a kind of trail of particles. It's starting to look a little bit more interesting, but it doesn't really look very graphic, and it's not really in the keeping with the rest of this project. It would be nice if it sort of echoed these streaks. And the way that we can do that is we can change a few parameters. By scrolling down in the particular settings, you can notice that the next part in the emitter section we have velocity, and this is the speed of the particles. And if you notice here, they're quite close together, and at this point they are further away. If I ramp this up, you can see that the particles move further and further away. So the velocity is to do with the speed. So if we set the velocity to be 0, then theoretically the particles won't move at all. However, we have these other two parameters, velocity from motion and velocity random. So we need to 0 these two as well. As the particles are essentially small dots, we still have a trail of small dots, and the reason for this is because our emitter size has a value. Now we can increase this, and you can see that it makes the dots further and further spread out, but to create a line, the easiest way is to set the emitter size to be 0. So now you can see we have a line that is occurring. And there we go. The problem here is that it does look a bit linear with kinks in it, and the reason for that is because the kind of emitter is jumping that distance from frame to frame. Now we do have ways to fix that. If you're working with particular version 2, then you can change the subframe sampling to fix this, and it will sample between each frame, and it will look at the position and interpolate, and there's a few options, and you'll get a nice smooth result. So that's one of the great upgrades with version 2. If you're still on 1.5, don't worry, we can get round it. In 1.5 what we can do is we can add some noise to the position values, and it basically will break that up and make it look less linear, and you access that in the auxiliary system section. In the physics section, and it's set to physics mode air. If we fold down air, and then you notice that we have an option called turbulence field. In here we can affect the size of the particles, and we can also affect the position. So if we scrub this position value, you can see that now our line is starting to wobble with noise. Sorry, I just moved the layer there. So let's set this position to 250, and you can see that as we scrub through now, our particles continue to kind of wobble with the, it's like a fractal that's moving them. So I've just done a quick RAM preview of that section so you can see that in action. Cool stuff. So you can see that that part is beginning to look a lot better already. So let's go in and change a few other parameters of the particular system. We haven't looked at any of the settings for the actual particles themselves, so that would be a good place to go next. So let's just fold this up and come to the particle settings and fold it down. If you notice from the RAM preview, let's RAM preview it for a little bit longer, you can see that the particles here all stay for quite a long time, even though the trail from the 3D render has disappeared. This is because the particle life is set to 3 seconds, so these particles are all going to live for 3 seconds, and we've just about gone over a second there. So they're going to live right until the end of our comp at this point. So we could reduce this down, and I think if we set this to something like 0.5, at that point they've all disappeared. And what will happen is, if we just RAM preview again, and here we go, and you can see that basically the trail draws and then it kind of wipes itself off. It's all a little bit dramatic. We could probably do that with some more finesse. So let's just stop the preview and carry on adjusting some parameters. At the moment we've got our particle type set to sphere with a sphere feather of 50, that's fine. We also have the option to adjust the size, so we can make this bigger or smaller. I actually think that 5 is probably okay. We can also randomly adjust the size, and you can see that if we increase the size, you can see that kind of randomness. I'm going to leave that at 0. The next option we have is size over life, and what we have here is we have a small graph, and what we can do is we can draw on this graph like so, and you can see that where I've drawn the size of the particles is changed. So this is at the largest size, this is the smallest size, and this is life from here to here. It says on here birth to death. So one good thing would be to make the particles scale down as they die. And we can use one of these preset graphs. These little pictures here are actually buttons you can click. So we can click to add a graph like this. So the particles start full size and end minimum size. I think what I'm going to do looking at this is I'm going to increase the life to maybe 0.7. Okay, and you can see that we now have the particles on for longer. If we choose this graph, when they're born they won't be visible because they'll be 0 size, and they'll scale up to full size and then scale back down. So if we come to this point in time, you can see that they're not quite visible at the point here, and here they are. So that's a bit more of a preferable result. Okay, the next thing we can do is we can come down and we can adjust opacity. I think that the opacity fading out as the particle scales down would probably be a good option. So the easiest thing here is just to choose the same graph, and you can see now that as they scale down they fade out too. So you just get a much nicer resolve rather than them just wiping off as they did a moment ago. So I've done a RAM preview so you can see the results of that so far, and I think that's looking pretty cool. It adds a nice touch to that top streak. So the next thing to do is to add this to the streaks below. So before we do that, let's just come in and rename this, and let's call this particular trail. So you may think what we need to do now is duplicate our particle system, create a new light, link the two together, parent the light to the other null, etc, etc. It's not quite as complicated as that. Let's first of all rename our light emitter top. Let's duplicate this, and this one I'm going to rename emitter middle. If we then take the emitter middle and let's parent this to the middle null, open up our position settings and let's zero these out. Let's select the bottom or the top null, press P for position, U to bring up all the animated parameters. And what I want to do is I want to take this expression and just click copy, select the middle null, press R for rotation. Let's switch off all the keyframes, alt click on orientation, and let's paste in our wiggle expression there. Let's take the top null and again let's do the same here. So we've got that wiggle expression on all of those nulls now. If we take our emitter middle and let's just adjust the X value to be 100 this time. Let's duplicate this. Let's call this emitter bottom. And this time we'll parent this to the trace null bottom. And let's zero these and set the Z to be 100. Okay, I just want to zoom out and drag through. And you can see we've already got a result with our particles. Now the reason for this is because particular is set to use any light that begins with the name emitter, and because all three lights begin with the name emitter, it emits from all three using the same settings. So using this technique we only need one particular layer and one particular effect, and we can create three essential particle systems. The other great thing about this is if we say take emitter middle, let's open it up and let's pick a blue colour. You'll notice that now that particle system has blue particles. If we open up this light settings and let's again pick a very light blue, and now we have particles that are light blue. At the moment all our particles are kind of hidden behind the news today, which is because we've got our particle trail layer at the bottom here. Maybe we could drag it up so that we see that in front of our text. That may look better. This is entirely up to you. As we drag across, we should see our particles fade out like so. So by creating one particular layer, we have now got 3 particle systems. So that's pretty cool stuff. We can always set this to a different composite mode so that it adds to the layer. That might be a little bit too much. Maybe put it to screen. Let's just check back with normal. Yeah, I think screen is slightly better, but add is almost a bit too bright. Cool stuff. So now we've got that set up and we have our 3 lights here. How could we add some more particles in here just to kind of enhance that effect? The easiest way is to just take our particular layer and just Control or Command D to duplicate it. And this time I'm going to call it particular dots. We may as well use the lights that we already have in there as our emission points, but let's just change a few settings in particular so that we get a kind of different result from this particle system. If we have 2 or 3 of these all on top of each other, we can create some pretty nifty looking results. So I think what I'm going to do is I'm actually going to just press U to show my keyframes, and this time I'm only going to emit say 100 particles a second, and I need to change that on both keys. But this time I'm going to give the particles some velocity. So let's come to our emitter settings, come down to velocity, and let's set this to 400. And you can see here that now we have a few dots showing up. Let's scroll down to the particle settings and let's choose glow sphere so that we have a little glow on them. And I think the life of these could be slightly less, maybe 0.3. So now you can see we just have a few small dots that are appearing as our lines draw on. It will make it perhaps a little bit more interesting. Let's set the size to be, say, 6, so they're a bit bigger. And let's set the size random to be 50, so that we get a few different sized dots. I think I might adjust the particles a second and set this to 200 for both of these keys, just so we have a few more dots. We don't want it being too fairy dust, but I think that looks possibly a little bit better. The other thing that we can do is we can adjust the colour. At the moment the colour is set from birth, which means it's using the colour from the light. We can choose over life or random from gradient. If we choose over life, this colour over life interface appears, and here we have a gradient that we can choose. And this is the birth colour and this is the death colour. So the particle will basically cycle through red, yellow, green, cyan and blue. Alternatively, we can choose random from gradient, in which case they will stay the same colour but they will randomly be picked from this gradient. We can use these presets as well at the side. So I've just clicked this blue one. I think this is quite a good idea because we have this kind of blue, not quite as cyan as this, but it'll be okay for a particle. And let's put white in the middle. Let's click over here, double click, and for this one let's create an orangey colour. So now our particles are going to be between this yellowy orange white and this cyan blue. I'm just going to kind of bring this round to here so it's not quite so cyan. So now we have these dots all appearing. If we then take our particular dots layer, and let's Control and duplicate this, hit return, and let's call this stars. Let's leave all the settings the same apart from for the particle type. Let's change this to star. Okay, and at the moment they're all in exactly the same place because we haven't changed any settings, so all our stars are on top of our glow spheres. But we can change that really easily just by coming into our settings, and in the version 2 this is in the main effects controls. But what we're going to do is come in here and we have the option to change the random seed. If we change this to a different value, you can put whatever value in you like pretty much. Click OK. Now although it doesn't look different, it's actually used the random seed to kind of randomize the particles emission. The random seed is there so that you can have several particulars in the same project. You adjust the random seed and all the random values will be different, otherwise all the random values will be the same. So although it looks exactly the same, if we solo our stars layer you can see they're here, and if we then solo the dots layer you can see the other particles being added on. So they're now in different positions. So all we've done to create our stars is just duplicate the particular dots, change the random seed and change the particle type to a star. So we've now got 3 layers of particles in our comp. It's all looking pretty cool. If we just rewind, let's take a look at the project so far. I'm going to just do a RAM preview and we'll have a quick look at that, and then we'll move on to the next part. Okay, so here we go. This is the project so far, and it's very near completion. As you can see, we've got all the large graphical elements in there now, and the particle system is working. The last thing to do is to add in the wipe and then just get the file ready for output. So that's what we'll be doing next. Let's just have one last look and then we'll move on and add in the wipe. As it happens in this example, we don't even need to create a mat or anything for our wipe, because really we're not going to be creating a wipe. We're going to just use the device for a simple cut. I position the globe so that at this point in time it actually fills the whole screen, hiding everything behind it. So what you could do is use this point for your cut point, and then in the next frame move to the next shot, and that would work pretty well because it's all moving so fast. That would effectively give the same idea as a wipe if people were watching it. However, if on this next frame we could see the back of our sphere or our globe, then you would need to create a mat so that you would only reveal part of your next shot, and then as the globe moves off screen it reveals it. So if you have positioned your sphere in such a way, then you're going to need to create a mat for that. The easiest way to do that is to take the News Today Globe and Text comp that we've already created and duplicate this. Let's just call this wipe mat and open that up, and you can see that we have our object buffer in here for the sphere already. We don't need the buffer for the text, so we can take that out, and we just need to fill these holes. So come to our 3D renders and we need to just bring in the appropriate object buffers. So object buffer 5, which is our lines. So if we set that to add, you can now see that that fills out. And if we then take object buffer 3 and set this to add, we now have a mat that we can use. So then the next thing that you would do is take your main comp, bring this into a comp of its own. If we then duplicate this comp, bring in our wipe mat. If you then take the top main comp layer and set this to use the Luma mat of the layer above, if we solo this now, you can see that we have isolated our globe. And the way that you would work is that on this frame here, you would drop in your layer behind and you would possibly mask it across to here, so that here we are still seeing our main comp, and then on the next frame everything's filled. You can then end your main comp here, and then on the next frame, if you still had the sphere visible, you could then drop in your layer in between these two. So the main comp that's been matted out so that it's just the sphere would be sitting above the next shot, and then as the globe wiped off it would reveal the next shot. The only thing you need to bear in mind here is that the globe, when you're animating it in 3D, does hit the top and the bottom of the camera. As long as it does that, you can quite easily mask your piece of footage and animate that mask to coincide with the sphere, and then you'd create a nice smooth wipe. In this example, lucky for us, we didn't need to do that. Okay, so that all looks pretty cool. If we come to the end here and just drag across, you can see that that just wipes to black, and that would work perfectly well. So that pretty much brings us to the end of the tutorial. And the next thing I'm going to do, I was just going to render it out so we can have a look at the result. But before we do that, if we were actually delivering this as a finished product, we would have to deliver it as anamorphic, and we could do that within this comp here. So if we open up the comp settings, first of all you'll notice that we're working at 1024x576, and I know a lot of you out there may well be using CS4 now, and Adobe have fixed one issue, which is the pixel aspect ratio, and we're working with clean aperture rather than production aperture. And what that essentially means is that we're actually working at slightly the incorrect width. And this is something that Adobe have only addressed in the latest version of CS4. I've left it like this because this is the default settings for CS3, and I think that's something for another tutorial. However, really it should be 1050. So if you want to read more about this, then by all means Google the CS4 After Effects aspect ratio, and it will come up with lots of results of why they've changed it. It's been 1024 by 576 for many years in many applications, and it's only recently that Adobe have adopted the BBC's guidelines to use the production aperture rather than the clean aperture. All that aside, let's continue. What we need to do is we need to switch this to be a widescreen D1 comp, and you notice that the size change, but also the pixel aspect ratio changes. So essentially the pixel changes from being square to non-square, and this squashes everything up. When this is played out on a widescreen TV, the pixels are a different shape, and it will stretch it all out to the correct aspect ratio, and it will look correct. So if you are supplying widescreen footage, then you need to supply it as anamorphic. One of the other things that I like to do is to add in an adjustment layer. So let's come down and just select our solids, and if we grab one that's the correct size, press F4 and let's switch adjustment layer on. Now very often what will happen, because TVs are made of fields, each row of pixels, and a television works by scanning down these in alternate rows, so this is why we have fields. You have upper and lower field, and the original reason for this is because when TVs were first created, the scans were pretty slow, so the guns would fire at the tube and it would scan down from top to bottom, and what would happen is the top of the screen would start to get slightly dark by the time the guns had reached the bottom, so you would see the scanning on the screen. Now to get around this is many years ago, the engineers thought what we would do is we would split the screen up and we'll scan it twice. So we'll scan every other row, and this is how fields came about. Now depending on the system depends on which order it scans in. Now we're not actually going to be outputting to fields at all, so that isn't particularly relevant, but what is relevant is the fact that a TV works like that, and because of this, and because of the thickness of the line of pixels, what can happen sometimes with very thin lines, particularly areas like here, is they may well sit between two rows of pixels on a TV. And what will happen is as it scans down, the line will flicker between the two rows. This problem is particularly obvious with very thin horizontal lines, but you'll often see it on the top and bottom of text elements, and as the text moves across the TV screen, it will flicker. And it does make your work look rather poor, and you've put all this time and effort into creating something, and then when you view it on a broadcast or a TV monitor, you get this flickering. So there are a couple of ways of getting around this. You can design your work so that it falls exactly in pixel space, which involves some maths and looking at the number of lines on a TV and making sure that any horizontal lines that you create are exactly in the right place. Now that isn't very prudent to creating design. I know that you're probably going to just lay things out and move them around until it looks okay. Another way of doing it is you can use the effect reduce interlace flicker, and what that does is it basically creates a very, very slight vertical blur. What I tend to do is add in a blur effect myself and control it that way. So if we come to the effect and add in box blur, let's check repeat edge pixels, and let's set the iterations to be, say, 2, because we want a reasonably soft blur. On the blur dimensions, we can set this to be vertical only. And the amount of blur that you need really depends on the amount of flicker, and you're much better to check this on a broadcast monitor when you're making work. But I normally use a value between 0.5 and about 0.8. So if we say 0.6, you'll notice that what's happened here on our computer monitor, you can see that everything has softened very slightly, and we have a very, very small vertical blur. Although that makes it look softer on a computer monitor, when you view this on a broadcast monitor or on a television, that will get rid of any flicker for you. and it will actually make your work look much more solid and more professional. The other thing that we should do is we should check for colour safe. Now you should really be doing this throughout your project. It's much better to kind of colour correct individual elements than try to colour correct the whole thing. So the correct way to do this really is to use a vector scope. There are some built-in effects that will help us to do this. The first one that you could use if you choose Effect Colour Correction is Broadcast Colours. And then if you check the correct format, NTSC or PAL, depending on which you're working in, and I like to choose Key Out Unsafe. Okay, and it looks like we're okay on this project because we're not getting any black areas, but what will happen is where we have unsafe colours, they'll appear black. And then if you add in Effect, Colour Correction, Hue Saturation and just place it before the broadcast colours, you can adjust the saturation and lightness of your image until that the unsafe colours which are disappearing reappear. And that gives you a pretty good guideline that the colours are now in the area of safeness. Now, one of the reasons that we actually have broadcast safe colours is because when a television signal is transmitted, it's given a certain frequency range to be transmitted on. At the same time, the audio is also transmitted. So we have a frequency range for the audio as well. Now, if you have certain colours that are too bright or too saturated, they actually move out of that frequency range. So that is why they're called unsafe colours. And what can happen on occasions, for instance, is if you have a really saturated bright colour, the frequency range of that colour when it's being broadcast will move into the frequency range of the audio, for instance, and this can cause problems with the audio such as hissing and things like that. So as I said before, really you should check it on a vector scope to check for your broadcast safe colours. We actually have a way of doing that within After Effects using a software vector scope, and the way that you do that is you use what's called Colour Finesse. Now you may or may not have this installed. I believe in some of the earlier versions of After Effects this comes as a separate CD, but you can check this in the effects menu, and if we scroll down to Synthetic Aperture you can see that we have Colour Finesse. So Colour Finesse opens, and we have a simplified interface that we can open here, which although it doesn't look particularly simple, if we open up the full interface you can actually fully appreciate the difference. So to open the full interface you click on the button here. When you do that, Colour Finesse opens up into an interface of its own, and it should look very similar to this. So here we can see our footage, and we have the option to look at the source and then the result after colour correction. We can also bring in a reference clip if we're colour correcting to things like that, and then we have this where we can split between our source and the result. We can also split between our reference and our original, and here we can see our luminance ranges. So let's just switch to the result for now. Over here we have a set of displays, and you'll probably recognise these down here as histograms, and here we have a curves display. We also have a waveform monitor here, and then we have a vector scope here. And when we're doing colour correction we're particularly interested in our vector scope. So we can come down here and we can select vector scope, and then we can look at this, and what the vector scope does is it shows us how our colour is distributed around a colour wheel. And as you can see here we have red, magenta, blue, cyan, green, yellow, and you can see that most of our colour is around the blue, cyan, and then over into the yellow, slightly into red. The further towards the edge of this circle we are, the higher the saturation, and in the very centre here there's no saturation whatsoever. So it looks a bit like a colour wheel that you might see when you pick out your system colour picker. Down here we have the option to adjust our hue, saturation, brightness, contrast, etc, etc. We also have the option to adjust specific areas, highlights, midtone, shadows. If we look at the Luma range setting here, we can see our highlights, midtone, shadows, and these different areas, white, grey and black, correspond to our highlight, midtone, shadows. So the Luma range here shows you which part you're actually going to be adjusting when you switch to these different tabs. So the idea with using a vector scope is that you need to make sure that your colours are not only inside this circle, but if you look in each section, red, magenta, blue, cyan, green and yellow, we have this small square with a cross in it. Imagine drawing a line from the centre of each of these squares to the next one. The aim really is to make sure that all your colours fall within that area. So if we imagine we have a line through here between our yellow and red, you can see that these colours here may just be falling slightly outside colour safe. I think we're pretty safe to go with this anyway, but if you had colours that are creeping up around here or over here, then you know that they're definitely unsafe colours and they're going to need fixing. So what do you do to fix them? There's a few different things you can do. The two things that you really need to adjust are the luminance of the image, or the brightness of the image, and the saturation of the colours. Now, depending on which colour is unsafe depends on which tool is best for the job. As an example, if you have a very bright red that's causing a problem, if you reduce the saturation of that red, what will happen is the red will tend to go pinky colour, which probably isn't what you want. So with a red or something, you're probably better off reducing the brightness. Whereas if you have a yellow, if you reduce the saturation of the yellow, that will probably work well, because if you reduce the brightness, it's going to tend to go towards a brown, muddy colour. Now with yellows, I would tend to push them more towards a kind of orangey yellow, otherwise they'll tend to go a little bit green. To be honest, it's really a matter of juggling these parameters, and as I said before, it's probably best, for instance in this example, if our yellow and orange is the only unsafe part of our project, we're probably better off going back to that layer in the original comp and just colour correcting that one layer. And then we won't be affecting everything else on our image. But if we do just take our saturation now and reduce it down, and if you watch the vector scope up here, you can see that all the colours pull towards the middle. We can click on here and type in an exact value. So if, for instance, we just say 98 to just reduce our saturation very slightly, and let's set our brightness to -2, you can see that also pulls it in. If we look at the source and then the result, the difference is very, very minimal. But if you look at the vector scope, you can see that we've managed to pull those colours in so they're more safe. Okay, so Colour Finesse can obviously do a lot more than correct our safe colours. It's a fantastic tool for grading and things like that, and hopefully this small introduction will entice you to get your feet wet and jump into this plugin when you're working on a project. I'm going to leave the settings as they are for now and just click OK, and we'll return back to our standard After Effects interface. So that's the end of this tutorial, and I hope you found it really useful. I'm just going to come to the main comp and I'm going to output this so we can have a look at the final result. So the final movie is rendered. I've actually opened it into QuickTime Player and saved out a compressed version using the H.264 codec just so we get a nice smooth playback. I'm going to just set it to full screen mode so we can have a look at the final result. It's been a long journey and hopefully you've reached the end. If you have, then give yourself a pat on the back. I also hope that you've learnt a lot through this tutorial. We worked in Cinema 4D and we went through quite a few options in the MoGraph module, specifically working with the cloner, and we used the cloner in object mode, and we also looked at cloning radial mode and using cloners within cloners. We used various attributes of MoGraph, including tracer to make our sweep NURBS and our glowy lines. We used various effectors as well. Along the way we created quite a few different materials, and we had a look at lighting using include and exclude. Once we'd created this and added some animation, we set up some object buffers and output a few multipass renders. We also exported the After Effects compositing file along with our camera information, and we brought that into After Effects. In After Effects we added in some background elements, used some color correction to enhance our render. We also used the object buffers so that we could isolate specific elements of our render so we could treat them individually. Once we'd done all that, we had a look at using Particular and linking that into our camera data and using the nulls that we'd exported from Cinema 4D to add in some particle effects. Finally, we had a quick look at using Colour Finesse just to check our broadcast colours and make sure that everything was safe for output. So I hope you enjoyed the tutorial. Well done for getting this far. It's been a lot of fun on the way. I've really enjoyed doing it. Thank you very much for watching, and hopefully this will inspire you to create lots of creative motion graphics. And if any of you work on this project and create some of your own work based on it, it'd be great if you could add some posts onto MotionWorks just to give us some comments on what you thought and show us your progress. Thanks very much for watching, and hopefully see you again on another tutorial in the future.